Again, good morning to all. So we'll start a study with our study of microprocessors and microprocessor systems with this topic, computer abstractions and technology. Now, ako lang ning decide na i-go over ning presentation for us to be acquainted and ma-orient atong selves with the terminologies and concepts na important in the study of microprocessors, but will not necessarily follow this route kaninga resource kaning computer organizations and design. Maybe we'll come back again later in the future sa kaninga kuan gyapon resource, but dili necessary nga atong next na topic is chapter 2 ani nga book, no? Or kaninga resource. It just seems appropriate man gud nga ang ilang chapter 1 nga makover na to, no? So although microprocessor systems is supposed to be a continuation of what we have learned from logic circuits, and although ang mga concepts and theories and the circuits that we've learned from logic and digital systems are really applicable here, but the world of microprocessor design, even just learning microprocessor systems, medyo daunting. Lahi siya nga klase nga world. I'm not sure if there are some of you na naka-watch yung mga videos o mag-start to read sa ingani nga klase nga mga topics. Pero ang mga microprocessor designers siguro and ilahang world is nasa ilang own nga language, no? And one of the objectives of this morning is to learn, no? Learn their language, no? Starting with initial foundational concepts and terminologies, no? Kana mahulog man gud nga ang microprocessor design is masyag merging of two worlds, the world of the purely hardware designers and the world of the purely software developers, no? Nasa in between. So we should be learning two fields at once, no? And medyo lisod na siya buhaton if wala na to na orient atong selves with that kind of field. So this topic is very much appropriate, no? At least computer abstractions and technology. I hope we learn much from this morning's discussion. So all of us are right here are aware naman of this quote-unquote law, Moore's law, right? Napabasa man siya sa paper ni Moore before, sa Electronics 1. I think so. And to summarize it lang, no? Moore's law dictates that every year, while gamay ang transistor technology, meaning for a specific working area or surface area, mas daghan tag mabutang amount of transistors, no? Or in fact, double siya every year or so. Yet, ang costs is gakuanpod, no? Gaubos, no? So through the years, we have more and more transistors in chips being produced at a much cheaper na price, no? But of course, has a ceiling man na hangganan, no? On where Moore's law will lead us. Pero I think di naman sila necessarily na to i-cover kung asa tama ng Moore's law. Basta kaya there will come a time na-reach na ang amount of number of transistors na pwede ma-mount sa isa ka integrated circuit or microprocessor with the current transistor technology that we have, CMOS. That's why engineers right now, not necessarily microprocessor designers, but engineers are researching more ways and even materials to replace silicon as transistors. So the computer revolution, right now we are in the age of computers, right? Halos tanan nato nga lihok kada adlaw magdepend gid tag computer. It might be when we hear the term computer, we're only referring to PCs and laptops, but appeal na diha actually ang kaning mga things. Even computers and automobiles or mobile phones. Our smartphones are in themselves computers. Okay, computers that are capable of sequencing and helping scientists in the Human Genome Project, hosting the World Wide Web and servers at Google. No? So if kanita lang kay computer, what really is a computer? Actually, the computer, the term or that part of our gadget that we have, example, ang cell phone or ang mobile phone, smartphone. The mobile phone could be considered a computer system, no? But ang computer dito mismo is ang thing, of course, that computes. That thing that computes, that makes the calculations. Okay, bali the central processing unit. So when we say computer, as we progress this semester sa kanyang subject, most of the time we're referring to that one, the central processing unit or the microprocessor inside our devices. No? So kana nga computer ang atong ginasabot. So there are many more types of computers that are not mentioned in this slide. No? Yet I think nasa next slides. So there are multiple classes of computers. We have PCs, servers, supercomputers, embedded computers. So atong what pwede ganit nga dili lang kita, no? What lay people know to be computers is just one class of computer, no? Personal computers or PCs, laptops and desktops. There are also server computers, servers. Kita na ba mo ani? Naka-observe na mo what servers are? Ang iyang itsura ani physical nga look is that of a system unit kanang atong ginatawag nga CPU, no? Kanang dako nga rectangle or cabinet kung asa nabutang tanan nato nga components like hard drives and motherboards and all those stuff. So usually kanang bas katong bata pa ta, no? Or tong apo ta kay walo. Mamaya atong nabalaan nga CPU, kanang dako nga rectangular nga box. Pero ang CPU dito is kato lang yung core nga nasa sulod. No? We can be forgiven man, or people can be excused for not knowing that. Okay na siya. So yan ang itsura sa server, no? Servers do not necessarily gani have monitors or even singular na mouse and keyboard. Standalone na siya nga system unit, no? Capable of hosting a myriad of applications, no? It's a network-based. It will be connected to the internet. It has a higher capacity, performance, reliability compared to PCs and laptops. No? Range from small servers, no, as small as any lang kani ako pag shape karon, to building size or room size. Isa ka room, isa lang na siya ka server, no? So there are servers or computers such as that these days. We also have supercomputers. Ang main purpose of the supercomputer is not, of course, for Facebook and doing Facebook and doing searches at Google. Pero for sure, ang Google and Facebook have their own supercomputers. No? It's a high-end scientific and engineering calculation type of computer. No? Wala gina ilang purpose. No? Tanan man, almost all man mo, no, nakaagi og sa ako sa MATLAB, no? Try to think of a computer nga dili lang kay naka-install MATLAB, but ihang yung main function is MATLAB lang yun. Dili MATLAB na software, but engineering calculation. Mo lagi na iyang purpose, no? A supercomputer that is capable of computing and maybe predicting financial na mga parameters, and so mo lagi na ilang purpose. Highest capacity but represent a small fraction of the overall computer market, no? So small fraction lang because mga pila lang pud mga company ang capable nga maka-afford og supercomputers. Another class of computers are embedded computers, na kani more practical ni actually pud sa ato, even though dili ta aware nga na-exist sila embedded computers. Mo nga mga computer ang naa sa ato mga appliances and things sa household, like ang microprocessor, di ba? Again, in our case, computer, microprocessor, okay? Ang microprocessor na nasa sulod sa remote control, no? Or even kanino, ang atong calculator. Sa sulod ani na ay embedded na computer or embedded na microprocessor. Atong digital na microwave, kinsa sa inyo na ay digital na microwave, so susunod diha na siya na computer. Mga sakyanan, no? Automobiles these days have onboard microcontrollers or microprocessors. So ang iyang difference ani, aside sa naka-embed siya, no, is specific iyang purpose. Isa lang yun, no? For the remote control, mo gina iyang purpose kung pulihan nimo na og microprocessor sa calculator, that will not work. Okay? Hidden as component of system, stringent power performance, and cost constraint. So yeah, embedded computers. We could also consider embedded computers ang Arduino Uno, ang Raspberry Pi, no? Pero those are customizable or programmable na embedded computers, Raspberry Pi and Arduino. So those are the classes of computers, no? So right now we are in the post-PC era. Di pa ganyan siya updated kay 2012 manggani ni. Notice the trend of the smartphone sales. And this was in 2012. Pila pa lang ka years since pag-introduce sa iPhone, aning time. Samsung wala, dili pa kaya nakadaghan ilahang smartphones. But smartphones are on the rise. Tablets are on the decline. Right now, observe man siya nato, pipilara ang avail yun o tablet or iPad kaysa smartphones or iPhone, no? So kung ato ning i-project, mas muda ko gid ang sales sa smartphone. Ang tablet gamay gani kadumdum ko ani. I remember this one kaning stage, college ko ani. Mo niyang pag 2010. Yeah, mo niyang paggawas ni Apple sa ilahang iPad, no? The very first generation sa iPad. Mo siguro niyang nag-boost sa sales. Nga kay nagpalit ato. Pero dugayan na discern siyo sa mga tao nga redundant naman kayo ang tablet or iPad if na naka-iPhone daan. Of course, na siya iyang own na specific uses or mas versatile. Magapon siya versatility kung naka tablet or iPad. Pero if we could see, no, na-decline siya. PC, notice, plateau lang, no? Medyo, kuan lang yun, kanang steady. Cell phones not including smartphone at this time kay although buo ilang sales pero taas sila ang rate. So again, right now we are in the post-PC era. People right now, even not necessarily rich people, could have multiple computers na in their own personal homes, no? Basta nakaiduha ka smartphone, nakaiduha ka computer, no? Aside siguro kung kinanglan gini mo ang computer for your work, kung gamer ka, right now, even the regular smartphone is enough. So those things that I have just mentioned are considered PMDs, or personal mobile devices. Battery operated, connected to the internet, no? Very cheap. Hundreds of dollars lang din. Multiply na to, even if multiply na to peso barato lagi hapon. Electronic glasses, no? Wala pa man nag-take off. So Facebook mag-develop naman sila sa no? smart glasses right now. Cloud computing. At the lighting zero of these slides, cloud computing was on the rise pa. Pero right now, cloud computing is norm na, di ba? Di na gani ta maka kanang kuan kayo aning term, because embedded na siya sa real life, no? Or sa daily living. Google Drive. Even lately, no? Wala na kayo nakita ang need to have kanang flash drive, no? USB. Okay, sa una, di kayo makita ang di kayo ma-appreciate ang need for Google Drive. So karon nga almost samot na karon nga online atong classes, then perinita connected almost 24/7 sa internet, no? And di na kaayo convenient ang magsig abli yung PC. Pwede na day wala tayo flash drive kung sige tag-access atong Google Drive, no? So that's cloud computing. Before, that was predicted to be where we are headed, and actually right now, no, 2022, na nagita dire ang cloud computing norm na, no? Dili na siya something I look forward kay, part na sa ato ang daily life. So when you say performance, talking about computers, how do we measure its performance? Is there one metric to know if a PC is, or a computer is performing higher than its counterparts?
Benchmark, sir.
So these are,
benchmark
Hello?
test.
Benchmarking, no? How will we benchmark on our computers? So these are just some of the metrics. Thank you for the term. These are just some of the metrics on how we will benchmark, no, or measure the performance of computers, no, through the algorithm na yan gina process, no. Not only the programming language, but how efficient it's, or how fast its compilers, no, its architecture. Isa po din sa atong no, atong balik-balik siguro na term pohon, architecture. What do we mean when we say computer architecture? How is it different from, or how is it similar to regular building architecture? No? One way also to measure performance is processors, no? Yung memory system, no? Dili kahit nato ni makuan ma-perceive if user lang ta of computers, memory systems, but if we are trying to study microprocessors, the ganda klase ng memory systems, no? Pwede day optimize ang performance of computers through the design of the memory systems, no? And last but not the least, not only that, but also the I/O systems, or the input-output na interfaces, determine how fast I/O operations are executed. So kaning mga concepts, again, ang purpose ng dato is to go over, no, the terms and the words. Kanitanan ato pagyaponing ma-cover in the future in a more excruciating detail. So karon malalagi tag definition of terms sa ma-aware ta sa mga words na panggamit sa microprocessor design. So 8 great ideas have influenced the design of microprocessors to the years. So design for Moore's law, abstraction, common gaze pass. So design for Moore's law. Of course, computer engineers or microprocessor designers through the years has always considered Moore's law to be their guiding light, no, sa design sa ilahang microprocessors. No? Double the amount of transistors, but lowering the cost. No, medyo kuan siya. Counterintuitive, pero that's what's happening, because of Moore's law. Using abstractions to simplify design. What do you mean when you say abstraction? No? Abstraction is the covering, compartmentalizing, ano ba? Sakto noon to pag cover or compartmentalize sa isa ka train of thought para dili na necessarily ma-complicate ang things. Example, analogy lang ni. We could study electrical engineering at using physics, di ba? Purely physics. So gabi nakalisod, no? Kung ato lang Fermi language is Maxwell's equations and Maxwell's equations, physical nga mga laws, electromagnetism. Kung kana lang Fermi atong it would be difficult for us to, kung di lang tanga level, no, it would be difficult for us to design more practical systems. Although that might be true. So we should take it a step further, no? Use abstraction. Ang next abstraction diha is ang kuanman, no? Ohm's law and KCL and KVL, di ba? Although Ohm's law and KVL does not violate man, no, any of the laws of physics, pero na sila gipang simplify nga things and gipang assume nga assumptions para pwede maka-design og circuits, even though, di ba? It's possible to design electrical circuits even though dili kayo in-depth atong understanding sa Maxwell's equations. Even though Maxwell's equation do govern electrical circuits, no? So that's one analogy of abstraction, no? Is the layering of the disciplines, no? Kung sa kani sa mga abstraction na ang ginakuan. From circuits to logic gates, no? Notice sa inyong pag-study sa logic gates before, you did not necessarily know what is the arrangement of components inside the AND gate or OR gate, di ba? Kabalo lang ang AND gate na isa ka output ug duha ka input, na if on ang input, on po ang output. Ano bitaw? So, wala ta kabaloon sa arrangement sa mga resistors o transistors sa sulod sa AND gate, no? So the study of logic gates is an abstraction, no? Abstraction of the study of in the design of digital systems, no? So ang next step actually sa logic gates is microarchitecture, no? Kung saan to pag-arrange ang mga digital components into something that we call a microprocessor na already. Yan na. Now, if nata sa pinaka-highest nga level sa abstraction, the highest level sa abstraction is the software, no? Software na nga level. Okay? Software. Diba? People could design very useful software, like the designers of Facebook, the designers of Zoom, no? Even if dili sila necessarily well versed, diba, sa how the microprocessors that run those software, even if di sa kabalo sa microprocessors, no, gagaran sa ilang software, no? You could design software even if di ta aware on how microprocessors work. So that's what abstraction is, no? Use abstraction to simplify design. when we dili man no not objective sa EE9 nga mag-design gyud og microprocessor, pero let's just for the sake of argument, no, mo na atong objective mag-design ta og microprocessors. It is very possible to be a possible lang, pero ligid siguro ko sure kung wise, no? But yes, it's possible to design, no, the architecture of microprocessors, even if wala ta naka-take og digital design class before, no. Lochada mas maayo magid kung kabalota og logic circuits and digital systems before ta mag-design og microprocessors. Pero if maayo ta, no, maayo ta nga computer architects, we could design microprocessors even if dili ta kabalo og digital circuits, no. Ato na lang nang outsource sa katong mga maayo gyud, no. So that's the power of abstraction, no. Natabunan na to tanan nga layer, no. Gikan sa physics nga layer taman sa circuits nga layer taman sa gates nga layer. Tabunan to tanan sa abstraction of computer architecture that I could be able to design microprocessors even if minimal lang akong knowledge sa digital circuits, no. So that's abstraction, no. Ako lang itong i-emphasize because it's a powerful na concept. Make the common case fast, no. What does this mean, no? So opposite ani is make the complex na case fast, no. Or ang iyang direct nga synonym is not to focus on complex cases, no. So make the common case faster, no. Para ma-explain ni siya, analogy na gihapon. Say for example, dito siguro gani ni analogy, kung gani siguro ni example kay computer man day gani gyud ang atong calculator, no. So what are the common cases sa calculators, no? We have the plus, minus, times, divide, magid na, no. So kung ato ning i-take advantage kaning nga great idea kaning making the common case fast, mas i-improve na to tong mga more common cases, no. And pwede lang nga dili kay na to i-improve ang mga complex cases. For example, the accuracy of pi, no. Dili man kay na siya nagig ka big deal if ang common gid nga case for the calculator is just the arithmetic na mga operations. So the same goes sa mga computers. As computer designers, no, as computer architects, kabalo man gyud na sila kung saan mga common cases, no. So dito sa mas more mag-focus mo to ilang mas ipapaspas. It's more logical that way, no. Kung kuan pa mas common sense kaniya to, no. So performance via parallelism, performance via pipelining, I won't go into detail here right now kay kaning mga concepts at talaga po ning madiscuss po, no. So kaning parallelism pipelining, these are one of the major topics good in microprocessor design, no? These concepts. We have fast microprocessors right now, no? And will be in the future due to these concepts, no? Parallelism and pipelining. Ato ni makaver po. Performance via prediction, no? Computer designers might have used computer software to perform some kind of forecasting or prediction. Hierarchy of memories. Ano yung ingon ganina, no? Memory system. No? So pwede na to i-improve ang performance sa computers by improving the memory system. So there is some form of hierarchy sad in memory systems. At the top are the more faster ones and at the bottom of the more slower ones. So naday mga fast nga mga memories, sir, and na po yung mga slow na so ato na ma-cover po, no. We think that there is only one type of memory in computers, pero gandi ay, no. Even memories nga dili ta aware, no, that are inside na sa microprocessor itself. And dependability via redundancy, no? It's very wise to to place much redundancy in the design of computer systems. But if mag-breakdown ng isa ka component or isa ka part, dili ra maapektuhan ang whole operation. So that's the redundancy. So these are some of the great ideas that computer designers and computer architects have used throughout the years, no, in the design of microprocessors. So, I think kung ano siya, exposition niya siya sa abstraction earlier. Pero more detail siya. What is below our program? When we try to use a computer software or application software, what is in the background, the backstage? So our application software is written in high-level language. No, couple naman siya taan. What are some examples of high-level languages? Could you count? Could you recount some mga high-level languages that you're aware of? So may mga example ani, guys. Or class. Kasi di maningog ang mga girls. Python, yes, Python. So pa, what languages are our applications written in? C++. Very good. Pa ba? Dagan pa man, di ba? Java.
Java, sir. Yes, sir.
MATLAB. Dili na siya application software. Ang MATLAB, no? Pero ang MATLAB ng language, dili siguro. But it's useful, no? To learn computation using MATLAB. Then below it, no? Below sa atong mga high-level languages are the tawag man yung lower level languages, no? Assembly language, machine language, machine code, na. Compilers, assemblers, no? Ato na silang ma-cover na mga terms later. Nakadog naman ang mga term when we speak of computers. Assemblers, compilers, no? What's the difference between the two? Ito na ma-cover later. So high level, we have high level programming or high level languages, assembly language, and machine language, no? Hardware representations. Like ako diri. So what's the difference of assembly language and this is machine language, no? More common term niyan is machine language. So what's the difference between assembly language and machine language? What's the difference between compiler and assembler? So the assembly language is the symbolic, no? So assembly language is more symbolic representation of machine instruction, whereas machine language is the binary representation of machine instruction. So binary man, binary. Meaning machine language is ones and zeros. Naman dito naman sa visual. While assembly language is something na masabtan pa nato, no? Masabtan pa nato ni siya. If assembly language programmer ta, dili pa kani siya lisod basahon, no? Napay mga commands ani nga written in English language. Just like this one dayo, namday dire. Add. No? Erase tanan. Anyway. So, yeah, do I need to define pa compiler and assembler? Naman na dire, no? A compiler is a program that translates high-level language to assembly language. No? High-level language is the language that we code in, no? We program in, like itong earlier, Python, Java, C++. Whereas the assembler is a program that translates the symbolic version to binary. No? Ang question is, unsaon ni pag-translate into ones and zeros, in only ones and zeros, no? That's the task of the assembler. Yeah. No need to define further. Next, components of a computer. I think even katong namo sa grade school or elementary na mo nang pinakauna nga topic sa computer ng subject, no? What makes up a computer? So again, this is just a big picture. This is how we simply organize, no, the components of a computer. We have the user interface devices, input, output, right? Sa pagdumdum sa una, itong bata pa mi, upat gida kabuk ang components of computer: input, output, storage, and processor, or memory and processor. Diba? So apil na dai karon is ang computer or ang network adapters, no? Wala gid ang processor. Okay, so user input or input interface devices like displays, keyboards, mouse. Storage device like what we normally know, hard drive, CD, DVD, flash drive. Kaya ni ginagamit karon, oh. And network adapters, NICs, network interface cards, routers, switches, okay. IP address, MAC address, kana. Skip na ako ni, dahil mo sabton. Diba, inside the processor, no? Which is also a component of a computer. Inside the processors are the data path. No? This is also a term. Take note of this one. Nga atong ma-encounter gapon in the future. Control path, no? Cache memory. Small, fast SRAM memory. This is SRAM. Static RAM, no? RAM, what is RAM? Random access memory. Redundant, you know. Small, fast SRAM for immediate access to data. So, the class memory class. When you say memory, siguro that the highest rank is a secondary memory. Mo ang mga hard drives. Katong ganina. Hard drive, solid state, USB, CD, DVD. Primary memory. What is primary memory? Mo yung mga ROM, di ba? Read only memory. How about primary memory? What is the primary memory of computers? Sa atong usually ginagamit ka term for primary memory. In contrast sa ROM. Start with letter R.
RAM, sir.
RAM, yeah. So na RAM, na ROM. RAM is asa gina-store ang mga immediate na data, no, for processing. Usually mo lang itong nailahan nga memory sa computer. Secondary memory o primary memory. Napo tayo ginatawag na registers, no? Register. No? This, kung hierarchy pa, yes, kung hierarchy pa, baliday niya itong, naman to kanina, di ba? Inverted, naman to triangle. Nasa pinakaubos ang mga slowest, nasa pinakataas ang mga highest. Supposed to be nasa lowest ang secondary memory. Registers are much faster than RAM. Of course, RAM are much faster than ROM man. But registers are much faster pag yun than RAM because registers are situated closest, no, closest to the CPU or the microprocessor itself. No, the CPU, to the ALU, to the arithmetic logic unit, no. Ako say kung yung processor mo, ALU magna yun sad ang ginagamit ng term. Then on top of sa register, we have cache. No, this one, cache memory. Mas pas-pas pag na sila. Or si other way around. Sige lang. Mubalik na po daan eh. Basta kay, aside sa secondary or primary memory, which are the RAM and ROM, napatay registers and caches. No? Sa'yo plain yung spelling. Cache. Familiar man tani nga term, mugawas mo nito sa hypermi sa atong pag kubi sa computer. Basta kay related gina siya sa memory. No? Cache. The Apple i5. So this is the what's inside the processor. No? Processor ni siya. Kasi ganig scale ni siya nga kuan. No? So inside the Apple A5 na processor are GPI opens, input-output, the data paths, na diha. Digital logic blocks, most probably na dili ang ALU, the arithmetic logic unit, ARM core memory name, most probably, DDR, SDRAM, SDRM, delay interface. When did this first appear? Apple A5. I think isa sa pinakauna nga, dili ang pinakauna, pero ang pinakauna nga iPad mini, mag A5 to siya nga processor ilang gigamit. No? Di ba naman, mo dumdum ba mo na naka-produce ang Apple sa una og iPad mini? Wala na kayo nakaron. Talag sa lang kung makita ang mga tao nagbitbitan na ito, magkalaan na ilang iPad mini siguro.
Android na
Pero,
sir.
ha?
Android ang ginagamit sir.
Android, sila, okay lang. No? So basta sa akong pagdumdum, a decade ago, ninigawa, so di kayo ni-updated ng mga slides. No? Dugay na kayo ng Apple A5. Sure ko ka ng mga processor sa inyo hang Android ka doon. Mas paswas pa na siya, ani. Alright. So we only have a few minutes, pero sila ako lang yung tiwaso ng mga few important na slides. We've already covered abstraction earlier. ISA, now what is ISA? This is also an important term. No? Masig mo require ko something from you related, ani. So when we say computer architecture or architecture, it mostly refers to this one, no? Instruction set architecture. I might require you to look up the different types of ISAs. So far sa akong madumduman ay duha ka pinaka-common na ISA. And sa kaning duha, say mga common nga implementations. No? So mapost ko assignment regarding aning ISA. If magbasa-basa bitaw ta aning bahalag big picture lang gyapon nga kuan. Overview sa mga different types of ISA, daghan na tag ma-learn. Daghan na tag ma-cover nga concepts na important sa pag-study sa microprocessor systems. Mas ma-widen ang atong perspective. Okay, so these are the different types of ROMs, network devices. We have the router, the switches, technology trend. Ang main na maging nga point ani is right now, Not right now. Right now, 8 years ago, 2013, the computing capability against cost of the integrated circuits are ilan man eh? 250 billion times that of the very first vacuum tube in 1951. No, not the very first vacuum tube. The vacuum tube that's in 1951. The vacuum tubes were invented for decades earlier. Yeah, the semiconductor technology that's very prevalent today is still the silicon pamangyad, no? And yung mga near cousins like the gallium, the germanium. Pero ilang ginatanaw nga material nga mo replace sa semiconductor, sa silicon as the main material for semiconductor kay kuan carbon, no? Organic based na semiconductor devices mo ilang gina research karon. So how are ICs manufactured? Not only ICs, no, but also the internal circuitry that composes modern day microprocessors. So ano yung process, no? This one is, I think, kanisha, no? So Intel Core i7 wafer. Ang Core i7, ang ikada isa lang ani, no? So pangtangtangon na to make Intel Core i7s. Okay. So before we end, to have a more visual na idea on how this is done, allow me to play a video. So imagine, no, ang atong modern day microprocessors are basically made of just plain sand, ba? course, processed na sand, but sand nonetheless. No? Sand stuff o metals na din na ang atong mga microprocessors. No? Very amazing. Arrange lang siya in a particular way. I-control lang niya ang pag-on o pag-off sa flow of electricity. Basically, mo lagi din ang purpose, diba, sa transistors, pag-control sa flow sa kuryente. And multiply lang nato na few billion and voila, we have our microprocessors. Okay, so I believe this ends our discussion this morning. No? Again, ang purpose na gid sa kanipang kuan, we'll have future discussions such as this one this morning. Pero the main purpose of that one was to make us aware of the terms and the words, the words that is used in microprocessor design and microprocessor systems. Okay. So if that was I hope that was very helpful, no, this morning. If ever man some of those are familiar to us na, mahulog na siya na review. Okay. So I hope there are no questions. Anyway, katong slides na akong i-use kanina, ako na to i-upload sa e-learn for your future reference. Okay. So as what I have mentioned earlier, I might ask from you an siguro assignment, no, kasi next meeting lang siguro na activity ako lang i-place next meeting, so that on Tuesday we'll not necessarily meet synchronously. As what I have said last time, once a week lang ta mag-synchronous. So next na to meeting is next Friday lang gyapon, same time, okay, 11 to 12. So on Tuesday expect na lang na ako ipabuhat nga asynchronous na activity. Okay.
Yes, sir.
Yes, sir.
Okay. No more questions? Is everything clear and all right?
Yes, sir. No more